Semi-permeable membrane means means that like it's like a security guard. Okay, some door is there. It will only allow the specific particles. Clear? Semi-permeable membrane means it will only allow the specific particle. Okay. So what is semi-permeable membrane? See, suppose you saw many times some raisins. These are raisins. Okay. You keep it in water, it will get. Then what will happen? Water will goes inside. Yes or no? Water goes inside. Now, so what will happen? See, this membrane is nothing but semi-permeable. What is that? They will allow water, but not other molecules, not other particles inside it. Clear? So this kind of membranes are known as semi-permeable membrane, and this phenomena is known as osmosis. Okay, this phenomena is known as osmosis. So what is osmosis? What is osmosis? First, we talk about osmosis. What is osmosis? Osmosis means that it is a phenomena. It is a phenomena where solvent molecules through a semi-permeable membrane SPM from pure solvent to the solution, from pure solvent to the solution. Okay, is known as osmosis. Is known as osmosis. Understood this thing? What is osmosis? Simple thing. Like you take a, let's suppose you take a this beaker type of thing. Okay, and in between you put a semi-permeable membrane. This side you take salt solution. Okay, and this side you take some pure water. What happens? After some time you will see this pure water goes to salt solution, going to salt solution. This kind of phenomena is known as osmosis. Understood? Yes or not? Tell. Yes, sir. Okay. Always remember, osmosis happen from low concentration to high concentration. Low concentration to high concentration. Tell me, where salt concentration is high? A or B? Where salt concentration is high? Huh? Tell, where salt concentration is high? A or B? Low. B, sir. B is a solution. There are solute particles more than A is a pure water. No. So where high concentration of solute will be there, solvent will go that side. Clear? Clear or not? Yes, sir. Okay. Now what kind of semi-permeable membranes are there? See, semi-permeable membrane means it is a film of cellophane which allows solvent molecules to pass through it. Okay, like this. Solvent molecule will pass through it. Okay, after some time it will see, you can do it in home also, or daily, in your daily life also you can see. Okay, two type of semi-permeable membranes are there. Okay, like if in your microscope, if you see the semi-permeable membrane look like this. Okay, and two type of membranes are there. Like one is natural membrane, which we see in vegetable origin, like this resin layer. Okay, egg also. Have you saw if you like break the egg very carefully, you see there is a membrane. Okay, this is nothing but semi-permeable membrane. Clear? Which like some water or something that can pass through it. Similarly, this onion membrane, these are all natural semi-permeable membrane. And this you can see cellophane paper, parchment paper. Okay, some inorganic precipitation called copper cyanide. We use them as SPM. Okay. So if you use them, and then we can do osmosis. Okay. Also our cell membrane, which our cell membrane, human cell membranes are there. They are also semi-permeable. Okay. Our cell membrane is also semi-permeable membrane. Clear? Okay. Now, okay, noted. Yes. Now, what is osmotic pressure? Understood? What is osmotic pressure? Coming back to osmotic pressure. Understood? One very important thing. Osmotic pressure denoted as pi. Okay. Osmotic pressure denoted as pi. So, you take this one side solution is there, one side solution is there, one side pure solvent is there. Okay. One side solution is there, one side pure solvent is there. Now, see, pure solvent coming this side. Yes or no? Pure solvent coming this side. Let's suppose some pressure I am applying this side. Some pressure I will apply this side, that this solvent will not come. Understood? The, the movement of the solvent particle from pure solvent to solution, if by applying some pressure, it will stop. The amount of pressure, that pressure is known as osmotic pressure. Understood? Understood or not? Yes, sir. Okay. Clear or not? What? Sarvesh. Clear or not? Yes. Understood? Like solvent particle coming inside of the solution. But in the solution, I am giving some pressure that it will stop. It will not come. That pressure known as osmotic pressure. Clear? Who raised hand? Me. Okay. Clear or not? Tell. Yes, sir. Yes. Okay. So, what is osmotic pressure? Write down. The osmotic pressure. The osmotic pressure is excess pressure that must be applied to the solution side, okay, of the membrane to prevent osmosis. Clear? Understood what is osmosis? Now, experimentally we find out that osmotic pressure is directly proportional to concentration of the solution and temperature. Clear? Osmotic pressure is directly proportional to concentration of the solution and temperature. Understood? Yes or no? Okay. So, if I remove this proportionality sign, you will get pi is equals to C into R into T. Now, what is R? First of all, what is C? C is concentration. Concentration of the solution. Concentration of the solution. What is T? T is temperature in Kelvin. Now, what is R? R is universal gas constant. You know this. You know what is universal gas constant? Used many times in grade 11. R value, remember R value, R is equals to 0.0821 or 1 by 12. Okay. Atom, liter, Kelvin inverse, mole inverse. Okay. Atom, liter, Kelvin inverse, mole inverse. Next, 8.314 joule, Kelvin inverse, mole inverse. Okay. Or 2 calorie, Kelvin inverse, mole inverse. These three values remember. Okay, 0.0821 or 8.314 or 2 calorie. Understood? Yes or no? Yes, sir. Clear? Now, what do you mean by concentration? Concentration means, let's suppose molarity. Concentration always will take in molarity. So molarity means number of moles by volume. Yes or no? So N by, just check it out. ঠিক আছে পড়াচ্ছি পরে মানে মা বাবা পৌঁছে গেছে okay listen so concentration is equals to number of moles by volume yes or no concentration equal to number of moles by volume into r into t clear or not
Yes.
now I can write this pi v is equals to nrt clear it seems to like some something you can remember no? Similar to like what similar to like pv equal to nr we use this for ideal gas but this is osmotic pressure it's quite different okay we are using this for solution understood or not okay
Yes.
so here remember v always you have to take in liter okay v is volume always you have to take in liter so you can see that pi depends on the n number of moles of the solute pi depends on the number of the moles of the solute so more solute more pressure you have to give yes or no more number of solute more pressure you have to give okay that's how you will find out that if you put resin okay if you put resin and normal grapes okay so where pressure is more like where the water particle will go easily obviously in resin because pressure inside molecules solid particles are low but inside which are filled already they there it will not go understood understood yes or no
Yes, sir.
okay so osmotic pressure is equals to pi is equals to n by brt or pi is equals to cr now modified is pi is equals to I into CRT. Okay, clear? This is the actual formula. We have to add I also. Clear or not? Till?
Yes. Yes, sir.
Okay, just
Sir, it goes from low pressure to high pressure or high pressure?
no low pressure to high pressure. Low pressure to not low pressure to high pressure. Low concentration to high concentration. Clear?
Okay.
Okay. One more thing. Remember, pressure. If you are talking about pressure, pressure units are there. Atmosphere is there. Okay. 1 atmosphere equal to 1.013 bar. Okay. 10 power 5 Pascal and 760 torque. Remember this. Sometimes they will ask in torque, sometimes they will ask in that. Clear? Should I give you one question? Tell.
Sir, can you show the previous slide for 1 second? Thanks.
Understood na? Any doubt?
No, no, sir.
Okay. Done.
Yes, sir.
Okay. So I'm giving one question. Try to do it. Try to do this. That calculate the osmotic pressure. Calculate the osmotic pressure exerted by a solution prepared by dissolving 1 gram of polymer. Polymer means 1 gram of some compound. Okay. Or molar mass 185,000 gram per mole in 450 ml of water at 37 degrees Celsius. Calculate. Okay, R value you should use 8.314, 8.314 joule mole inverse Kelvin inverse. Clear? Go ahead, I'm giving you 4 minutes. Easy question. Time starts now. 3.0928. Okay, let's see. See, we know pi is equals to CRT or pi is equals to N by V RT. Yes or no? Now, one by one we will find out first. N is equals to given mass by molar mass. So 1 by 185,000 mole. Yes or no? V is equals to, what is the V? 450 ml. So 450 ml means 450 by 1000 liter. Clear? R value already I told 8.314. Okay. R value 8.314 and T value, T is equals to how much? 37 degrees Celsius. So 273 plus 37 is equals to how much? 310 Kelvin. So just put the values. So pi is equals to 1 by 185,000. Okay. Multiplied with 8.314 into 310 into 1000 divided by 450. Okay. Now calculate what you are getting. We'll get 0.03. Tell me, what is the problem where you get incorrected? One decimal place wrong, sir. Okay. Okay, so answer is 0.03 and answer will come in atmosphere. Clear? Clear or not? Understood, Kirti? You're not responding. What happened?
Yes, sir.
Understood or not?
Yes, sir.
Now listen. Now, based on osmosis, there are three type of solution is there. Based on osmosis, there are three type of solution. Okay, one is called isotonic solution. Isotonic solution. Okay, one is called hypertonic solution. Another one is called hypotonic solution. Hypotonic solution. Now, sir, what is isotonic? What is hypertonic? Almost you know, iso means same, right? Iso means same. So when you take two solution, A and B. When the osmotic pressure of A will be equal to osmotic pressure of B, that kind of solution known as isotonic solution. Now in this case, what will happen? No exchange is there, yes or no?
Yes, sir.
No exchange is there. So that is called isotonic solution. So pi A equal to pi B. Now pi A equal to pi B means CART is equals to CBRT. Simply I can say that Ca is equals to Cb. Both concentrations should be same. Okay. Clear? When osmotic pressure will be same, when both concentrations should be same. Next, hypertonic solution and hypotonic solution. Simple thing. If you take two solution A and B, let's suppose pi A is more than pi B. Okay. Osmotic pressure of A is more than osmotic pressure of B. Which one is higher? That is known as hypertonic. Hypertonic. And which one is lower? That is known as hypotonic. Now you have to tell me which side the solvent particle will go, from hypertonic to hypotonic or from hypotonic to hypertonic? From A to B or B to A?
B to A.
B to A, right? Low concentration to high concentration. Clear? Yes or no? Here also you can tell that Ca is lower than Cb. Ca is more than Cb. So low concentration to high concentration always it will go. Okay, so that's why see generally what happen, our blood have the concentration 0.9% W by V NaCl in our blood. Okay, now let's suppose you drink salt water, too much salt water. What will happen? Your blood cell will burst or your blood cell will shrink. Tell. Your blood cell will burst or your blood cell will sink. Hello.
Sorry, can you
I am asking that our blood cell, okay, having 0.9% W by V, and you are drinking salt water or you are eating salt. So in that case, your blood cell will burst or your blood cell will shrink.
Shrink.
Shrink. Think about it. So what will happen? See, if I put solution more than that, it will getting shrink. Why? Because outside of the blood cell, what happened? The concentration increased. So all the solution will come outside. Yes or no? All the solution inside, all the salt solution coming outside, and that is known as plasmolysis. Very plasmolysis. That's
Sir,
why.
can you repeat it?
See, listen. What happened? Let's suppose this is our blood cell. In this 0.9% W by V. Now, if you drink more salt water, more salty thing, so what will happen? Outside of the blood cell, okay, outside of the blood cell, what happened? The salt concentration increased. Yes or no? Because salt concentration increase, they will want the inside salt wanted to come outside. Yes or no? Inside salt wanted to come outside. So when inside salt wanted to come outside, what will happen? Your blood cell getting sink. Here or not?
Yes,
That
sir.
that process called as plasmolysis. That process called as plasmolysis. But instead of that, let's suppose in your blood is there, but outside salt concentration getting low. So then what will happen? Then what will happen? See, then this is blood cell.
But
All the salt will go inside. Yes or no? And
Yes, sir.
it will get blast. So then therefore we will have swelling. Swelling happen. Clear or not? So swelling when happen? When you use hypotonic solution. When you use hypotonic solution. Clear? And plasmolysis when happen? When shrinking happen? When you use hypertonic solution. That's why in hospital they get that saline water. Yes or no? They get saline water. Okay, or any injection or saline, whatever. The concentration should be matched with our blood cell. If it is not matching, then some problem will be there. Either blood cell will shrink or blood cell will. That's why whenever they are giving saline now, the injection or whatever, okay, that concentration should be matched. Clear or not?
Yes,
Understood?
yes,
sir.
sir.
Isotonic, hypertonic, hypotonic.
Yes, sir.
Clear? Any doubt? Anyone have any doubt?
Sir, hypotonic means it will shrink.
Hypotonic means it will swell.
Okay,
Hypotonic
sir.
means lower concentration and lower pi value. Clear? Clear or not?
Can you write it down in the previous slide, sir?
See, hypotonic means lower concentration, lower pi value, and lower pi value means lower concentration. Simple. And hyper means more. Obviously. Okay. So more pi value and more concentration. Understood? Yes or not?
Yes, sir.
Okay. So let's do another question. Tell. This is CBSE 2019 question. Let's see who can tell. Do you understood the question? Tell me. Hmm? Read the question at least once or twice, you will get an answer. It's a very easy question. Simple. Tell, Sarvesh, tell. Tell me just how to do. That's enough.
So first we should find the number of moles.
Hmm.
I got 0.2.
Number of moles of glucose is
0.2.
whatever, 36 by 180, right?
Yes.
That's it. Let it be. Okay. Next. So
So
concentration of glucose. What will be the concentration of glucose? Same 36 by 180. Yes or no? Divided by 1 liter. So 36 by 180 molar. Clear or no? Clear or no?
yes.
Now we know pi is equals to CRT. So can I write pi 1 by pi 2 is equals to C1 RT by C2 RT because they told same temperature. Yes or no? So RT gone. Okay. So C1 by C2 is equals to pi 1 by pi 2. We need C2. So C2 is equals to C1 into pi 2 by pi 1. Now tell me, what is the value of C1? C1 value 36 by 180. What is the value of pi 2? 1.52. And what is the value of pi 1? 4.98. If you calculate all of them, you will get, hello? Yeah, if you calculate all of them, you will get 0.0061, I think. 0.006061. Okay, clear or not? Mole per liter. Understood? Simple question, easy. Understood, Kitty? Yes or no? Tell.
Yes.
Okay, now in this all the cases I value is equals to 1. Okay, now our next topic we are going to learn, that's called I. Okay, what is I? Finally we are going to learn. Okay,
Yes, sir. Done.
Done. Asa now. So what have we learned till now? That colligative property means directly proportional to number of particles. Colligative property means colligative properties means it is directly proportional to number of solute particles. Clear? Okay. Clear is on. But tell me one thing. Let's suppose you are taking a solution and you are adding NaCl. Okay. I'm adding 100 molecules of NaCl. But actually, after resolving, NaCl molecule will convert into Na plus and Cl minus. Yes or no?
Yes, sir.
So 100 molecule convert into 100 Na plus 100 Cl minus. So total number how much it come? 200. We do calculation with respect to 100, but total number actually 200. Yes or no?
Yes, sir.
So this is because of what? Because of dissociation happened. This is because of dissociation the number increased. Clear or not? Because of dissociation number increased. Similarly, if I add acetic acid, so already I told you that acetic acid in presence of benzene, in presence of water, it will associate, right? It will association happen. So I am taking 100 acetic acid, but actual working as 50. Why? Because of association. Clear or not? So this is because of this abnormality in colligative property we saw. Okay. Because of this, like the value of, let's suppose, pi value should come 2 bar, but it is actually coming 4 bar. Clear? We calculating 2 bar, but actually coming 4 bar. So what is the problem? Okay, so because of this association and dissociation, number of particle increase or decreased. Clear or not? This thing understood or not? This thing understood or not? So to remove this, we use a factor, already you know, we use this factor called Van 't Hoff factor. We use this factor called Van 't Hoff factor, which is denoted as I. Okay, Van 't Hoff factor I. What is I? Simply remember, I is equals to normally. What is calculated molar mass? Calculated molar mass, molar mass of solute divided by observed molar mass. Observed molar mass of solute. Either I can be calculated like that. How to calculate I? Or else observed colligative property. Observed colligative property. Okay. See, both things different. Observed colligative property divided by calculated colligative property. Clear? Why? Why I am writing like this? You know, colligative property directly proportional to number of moles. Yes or no? And number of moles inversely proportional to molar mass. So that's why if you are taking molar mass, then calculated by observed, and if you are taking colligative property, then observed by calculated. Okay. Okay. Now remember, when association happen, always I value less than 1. Okay. When dissociation happen, when dissociation possible, I value more than 1. And when nothing possible, I equal to 1 always. Okay. I equal to 1 always. Now how to find out I value? Like NaCl. NaCl. So NaCl dissociate into 2 parts, Na plus, Cl minus. Yes or no? So I value will be 2. Clear? Now if I ask you what is the I value for CaCl2? Tell. What is the I value for CaCl2?
3.
3. Yes or no? I value will be 3. What is the I value for glucose? Tell.
22.
Wrong. I value for glucose is 1. It will not dissociate. Glucose will dissociate into parts, into ions. No. But here you told na calcium chloride dissociate into Ca2 plus 2Cl minus. So total 3 ions. But glucose will not dissociate. Urea, glucose, they will not dissociate. So when these are given, I value automatically 1. Clear?
Yes, sir.
Okay. So so this thing now from here, this Van't factor, some type of questions they will ask. What kind of question? They'll ask degree of dissociation. Degree of dissociation or association. So how to calculate degree of dissociation? Remember degree of dissociation is that denotes at alpha. Alpha is equals to I minus 1, n minus 1 for dissociation. Okay. Alpha equal to I minus 1 by n minus 1. What is n? N is same. N is nothing but number of ions. Clear? Number of ions. Now, let's suppose NaCl. Okay. NaCl will dissociate 100%. So, for this alpha value equal to 1. So, tell me what is the I value? If alpha equal to 1, what is the I value for NaCl? From here you can calculate. So, 1 equal to 1 I minus 1 by 2 minus 1. Yes or no?
Yes, yes, sir.
So, I value 2. Clear or no? I value equal to 2. So when 100% dissociation happen, I value is equals to n. I equal to n. When not 100%, then you have to calculate. Okay, that value will be given. Okay. Next, degree of association. These two remember very important. Degree of association. When degree of association given or dissociation, whatever. Okay, then alpha is equals to I minus 1 by 1 by n minus 1. Okay, I minus 1 by 1 by n minus 1. For example, you take acid acetic acid. So for that case also the association, let's suppose 1. So 1 equal to I minus 1 by 1 by n minus 1. So tell me what is the value of I? What is the value of I? Any idea? So for association, what it will become? 1 by 2. Okay, I minus 1 by 1 by 2 minus 1. Yes or no?
Yes, sir.
How? See, n value, how I am taking 2. See, 2 molecule associate together. So, 1 by 2 minus 1. Clear? So, here from here you will find out that I value is equals to half. Okay? Clear or not?
Yes, sir.
I value equal to half. So, see, for association, alpha value, I value always less than 1. I value always less than 1. And dissociation, I value less than, greater than 1. You see? Now,
Sir, is it also not equal to 1 for degree of
it,
association?
huh? Tell, tell.
Nothing. Nothing.
Equal to 1 means there is no association. I'm writing this. Okay. Remember, when I value equal to 1 means behaves normally. Solute behaves normally. Okay, no dissociation, no association. When I equal to half, then dimer formation, dimer formation, association. Okay, association. When I equal to 1 by 4, then tetramer formation. Tetramer means P4. You know P4? Tetramer. When I is equals to 1 by 8, there is molecule like sulfur, S8. Okay, clear or not? When I equal to 2, then what happened? Dissociation into 2 ions. Dissociation into 2 ions. When I equal to 3, dissociation into 3 ions and so on. Clear or not? So finally, what can I write? Final. Okay, finally I know that P naught minus P by P naught is equals to I into mole fraction of solute. Another one, delta TB is equals to I into KB into M. Okay, delta TF is equals to I into KF into M, and pi is equals to I into C into RT, or we can write pi V is equals to I into N into R into T. Clear?
Yes, sir.
See, this is the most important topics in you know, in this chapter, because from here questions will come. Colligative property, mainly questions will come from here. Okay, clear or not? Tell. Can I give you one question? Question. Everyone should have to do this question. Determine the amount of CaCl2 whose I value given 2.47. Okay, I value given 2.47 dissolved in 2.5 liter of water such that its osmotic pressure its osmotic pressure osmotic pressure is 0.75 atmosphere at 27 degrees Celsius. Okay, R value you have to take 0.0821 atmosphere liter mole inverse Kelvin inverse. Yeah, go ahead. I'm giving you time, 5 minutes. Tell what happened? What happened to Ashmita and Kirti?
No, so something was wrong with the calculation of modes.
Okay, so we know simply pi is equals to n by v at t. So first find out n. N by not n by v at t. I into n by v at t. First calculate n. N is how much? N we need to find out actually. W by molar mass. So molar mass, what is the molar mass? W by 111. Yes or no? Yes or no? Pi value given. Pi value 0.75. Achha. Next I value given 2.47. Next V value given. V is given 2.5. And R value given 0.0821. And T value given 300. Put all the values. Okay. Put all the values. So pi is 0.75. I is 0. I is 2.47. 2.47. Next W by 111 into 2.5. Okay. W by 111 into 2.5. Next R into T. R is 0.0821 into 300. Now almost you can see here this is 2.5 and this is almost 2.5. You can cut for without calculator calculation you can cut. So W is equals to 0.75 into 111 divided by 0.0821 into 300. Okay, so how much you will get? Any idea? Calculate. You will get around 3.4 gram. Okay. Hello.
Yes, sir.
Understood how to do?
Yes, sir.
Or else directly you can find out the n value and finally you can multiply with you can multiply with 111. Okay. Okay, so this chapter actually over. Now we'll do some recap on this chapter. Okay, whenever you are doing revision, you should like this do revision like this. Okay, like which chapter? Solution. Okay, I'll send you this also. Solution. In solution chapter, what will happen? See, first thing we learn what? Type of solution, types of solution, yes or no? Like solid solution, gaseous solution, okay, liquid solution, solid in liquid, gas in liquid. Clear? Next, what do we learn? Methods of concentration or concentration terms. Concentration terms. What are concentration terms? W by W, W by V, V by V. Okay. Mole fraction, ppm, ppb, and molality. Yes or no? Molality and molarity. Yes or no? Hello.
Yes, sir.
Okay. Next, Acha, this I told you. Which one are temperature dependent? These are temperature independent. Why independent?
They don't depend on volume.
They are dependent on volume, and these are temperature dependent. Okay, this thing we learn. Next, we went to solubility. We went to solubility. What we learn in solubility? That what is solubility and all. Then we learn solubility in solid in liquid, solid in liquid. Then dependency on temperature, dependency on pressure. Okay, solid in liquid doesn't depend on pressure. Okay, no effect. But temperature directly or indirectly? Directly or inversely? Tell. Solid in liquid. It depends. If it is exothermic, then in inverse, and if it is endothermic, then directly, right? Depends. Two types. Okay, and then we learn in gas in liquid. Gas in liquid, I told you, directly proportional to temperature. Yes or no? Because exothermic or gas in liquid always, directly proportional or indirectly proportional?
Indirectly.
Exothermic, so indirectly proportional, and effect of pressure directly proportional to pressure. Clear? Here we comes to Henry's law. What is Henry's law? Tell.
Partial pressure is directly.
Partial pressure equal to Henry constant into mole fraction. Clear?
Yes, sir.
Next, liquid in liquid. Liquid in liquid we learn. Liquid in liquid we learn. There we learn about ideal solution, non-ideal solution, ideal solution, non-ideal solution, and finally, which is the most important thing, that is called Raoult's law. Raoult's law. What was Raoult's law? Raoult's law told that partial pressure of vapor pressure or partial pressure is directly proportional to the mole fraction of the solid. Okay, that Raoult's law will discuss, and then we learn about colligative property. Then we learn about colligative property. Okay, colligative property. Four colligative property. Okay, when you are writing, when you are revising, always write RLBP, EBP, and their formulas. Okay, represent in freezing point, and last osmotic pressure. Okay, and we learn about I value. Okay, what is I value? What is I? What is I? I is Van Top factor. Okay, Van Top factor. Achha, one more thing I told you, I think, didn't tell you. Listen, here one more topic is there, small topic called reverse osmosis. Reverse osmosis. Listen, what is reverse osmosis? See what I told. What is osmotic pressure? Osmotic pressure means, see, A is there, B is there. A is, let's suppose, solvent, and B is solution. What is osmotic pressure? Some pressure I am giving here, that the osmosis will stop, right? Yes or no? Some pressure I will give here, that the osmosis will stop. But what happens if I give more pressure than osmotic pressure? Think about it. If I give more pressure than osmotic pressure, what will happen? Whatever the solute particles here, whatever the solvent particles here, they will come this side, yes or no?
Yes, sir.
If I give more than pi, what happened? Whatever the solvent particle, they will come this side. Okay, this phenomena known as reverse osmosis. And by this phenomena, we used to purify water, purify seawater. Seawater, you know, there are too much salt is there. Okay, like in all of you are in Chennai, so you know seawater, ocean water. Okay, you take ocean water, you take semi-permeable membrane, and you have to add more pressure than osmotic pressure. So what will happen? All the solvent will come this side, and it will become pure. So this is known as reverse osmosis. Okay, question will not come, but they will ask what is reverse osmosis. Clear?
Yes.
Okay, so what is reverse osmosis? Tell. Reverse osmosis means when a pressure higher than osmotic pressure, okay, higher than osmotic pressure is applied to the solution side. Okay, to the solution side, then solvent will comes to the like solvent of the solution will comes to the pure solvent side. That is known as that is known as you know, reverse osmosis. Okay, and this I told you example, purifying seawater. So purifying seawater, we use the semi-permeable membrane cellulose acetate. Sometimes MCQ they will ask cellulose acetate. Okay, the semi-permeable membrane we are using uh, in reverse osmosis of water, that is called cellulose acetate. Clear or not? Tell.
Yes.
Okay, so this chapter completed. By the next day we will start electrochemistry, and so this question, some questions I will send. So let's do some questions now. Tell me, as this one we did, right? Yes or no?
Yes, sir.
Okay, uh one more question. Do this question. One last, this one only. Two more, one more question, this one. Two. Read the question. So first find out the Van Top factor. Okay, I will. As a 0.5% aqueous solution is W by W given. Okay, W by W given. You have to find out the molarity first. Okay, do it. It will take time little bit. What happened to Kirti? Doing?
Yes, sir.
Try. Very less response from you. Right? Done.
No, sir.
Not getting, or I have to do calculation part. Chemistry understood or not?
Yes.
Calculation can be done. So what is given? W by W given 5%. That means KCl is given 5 gram. Okay. Weight of KCl given 5 gram. Okay. Yes or no? What is the molar mass of KCl?
0.5.
What is the molar mass of KCl?
74.
Hmm? Molar mass of KCl 74.5.
5.
Very good. 74.5. Achha, next. What is the mass of water? That is 95 gram. Clear? Okay. Mass of water is 95 gram. Now, what is delta TF? Delta TF equal to 0.24. You can take it as 0. You can take it as 0.24. Okay, 0.24. Now, KF value given 1.86. We know delta TF is equals to I into KF into M. Okay, so I is equals to delta TF divided by KF into M. Now M means, what do you mean by M? M means W of KCl by M of KCl into W of water into 1000. Okay. So I'll put all the value together. So delta TF is 0.24 divided by KF value given 1.86. Okay. Now molarity W of KCl is 5 into 1000 divided by, if I divide it will come offside. So MF KCl is 74.5 and W of H2O is 95. That's it. Now one go calculation. Okay, always do calculation in one go. That's why you will get less error or something. Clear? So 1.86 by 5 by 1000. So what is the value? 0.18. I value you are getting, I think, 0.18. Okay, yes or no?
Yes, sir.
I value 0.18. Now what do we know? Alpha is equals to I minus 1 by n minus 1, because KCl will dissociate like NaCl. Achha, what is the value of N2? Yes or no? So 0.18. Wrong. I think something wrong with it.
So 0.5%.
Eh?
W by W.
Oh.
That's what I told in the beginning.
Okay. 0.5%. That's correct. 0.5%. So this will be 99.5. 99.5. Okay. Take as 99.5. Okay. My mistake. 0.5. So calculate. Then what happened? 0.5 and 99.5. So we'll get 1 by that's why. What is the mistake? Because in this case, always greater than 1. I value always greater than 1 will come. So we'll get what? 1.91 minus 1 by 2 minus 1. Yes or no? Okay. So how much? 0.9 by 1.
0.
Okay. So 0.9. Simple. So degree of dissociation will be 0.91. You see? Now this thing you have to write in board exam. If it will come, you have to write that we know delta TF equal to this, delta T, then these are the values given. Then if we apply, we'll get the I vector factor, and we know degree of dissociation alpha is equals to I minus 1 by n minus 1. Then therefore we are getting this alpha value 0.9. Clear? Okay. Also you have to write KCl why n equal to 2, because KCl, so you have to write this equation. KCl dissociated to K plus Cl minus. Okay. Next, one more question.
Sir, they definitely give calculator.
No, exam they will not give calculator. I have to calculate. Clear? So that's why I'm telling that at the end you have to make like this, that as much as you can cut. Understood? As much as you can cut. Like 995 by 5. You can take the approximation here, 1000 will go. Okay, then 745 divided by 5. Okay, one or two multiplication you have to do. That's why they are giving time. 3 hours they are giving. Okay, within 3 hours you have to do how many questions? 10 plus 5, 15 questions. Clear? 15 to 16 questions only. Apart from MCQ. MCQs are there now. Apart from MCQ. Okay. So these questions will come in other in your subjective time. Clear? Go ahead. Also remember when you are writing the exam, okay, first do the question, first find out the answer properly. Then write in the exam paper, write the exam properly in the in the exam paper, exam sheet. Write that after that. Okay. I remember when I gave exam in CBSE, when I gave board exam, I like before night I know what questions are going to come, okay, and which page I am going to write in chemistry and mathematics. So that practice you need to do. Understood? Clear? You will get many or question or like many alternative questions also you'll get. Clear? Like this question you can't do, then another question you should. Okay, so like that. Mostly, I will prefer for you. Mostly start with subjective question, writing question. Okay, keep the page aside, then start the writing subjective question. At the end, in 30 minutes or 40 minutes, go for MCQ. If we start with MCQ, your mind will not work for subjective questions. You will do wrong. So first complete subjective question properly with proper handwriting. Okay, then do MCQ. Okay. So this question homework, I'll give some homework also. Easy question you can do. Okay, easy question. Two solution given, they are isotonic to each other. You need to find out the mass of glucose present in the solution. That's simple. Simple. Clear? Any doubt? Okay. Okay. So, like Sarvesh, from the next chapter, we don't need no need of this chapter actually. Okay, the next chapter electrochemistry, we don't need of this kind of any question, any concept in the next chapter. We need one concept needed, that is concentration terms. Okay, one concept that is needed, that is called concentration terms. That you have to properly you have to go. You if you can check the lecture 2 you can go through it. We have all the concentration term properly discussed. Any doubt you can ask me. Okay, anyone? Kirti? Any doubt? Huh? What happened? Okay, so revise this, do the question. I will send many questions. Okay, I'll send many questions, many you have, all of you have two notebooks actually. Okay, so in that other notebook, this note on one you are taking notes, and another notebook you have to do that questions. So another notebook, do that questions, whatever I am saying. Okay, so if you do all the questions, you can't stop. Okay, any questions come, automatically you can, including MCQ also I will send. Clear? And one test I also take, then not now, in May month I'll take one test. Okay, after completion of electrochemistry, both chapter together I'll take. Okay. Okay then. If you have any doubt, you can ask, or else bye. Good night.